Hey, what's up everybody? In this video I'm going to show you one way to model how an ionic bond forms. That of course would be between a metal like calcium and a non-metal like bromine, and we'll use these two as our example here, but you can apply this exact same process to really any set of metal and non-metal that you get. So the first thing would be to look up on a periodic table exactly how many valence electrons each of these things have. That of course is based on the column that they fall in on the periodic table. At least that's the fastest way to do it. Starting on the far left, the alkali metals who all have one valence, and then it just increases as you go across, leading up to 8 valence electrons with your noble gases. Calcium is right here, so it's got 2 valence electrons, and I'm going to do a dot structure to show those 2 valence electrons with just 2 dots. Bromine is in this column, the halogens. That means it's got 7, so I'm going to go 1 valence electron on each side first, and then we'll double up for the 5th, 6th, and 7th valence electron. The second step is to start showing how these electrons are going to change. And when it comes to ionic bonds, which is what we're trying to model, you've got metals which are always going to lose their electrons. They hold on to their electrons very loosely, and non-metals that have a really strong attraction to electrons. So what ends up happening is the electrons are transferred. That's usually the key word. They will literally move from the metal to the non-metal, and we represent that transfer process with an arrow. So we'll start with this 1 electron on top of calcium. You want to be very specific about which electron is moving. It's this one, and it's going to take that, essentially that empty space right there with this 1 electron bromine has that does not yet have a pair. That gives bromine the 8 total valence electrons that it needs to be stable, and I'll represent that stability with a happy face next to my bromine here, just to remind myself that this bromine is essentially now, we'll say finished, but really the word is chemically stable because it has a full octet. To finish the model, you have to basically just keep doing this until all of the atoms are stable, until they all have octets, until they've all lost or gained the amount of electrons that they need to lose. So my bromine atom here is good, but my calcium is not. It still has this 1 extra valence electron. So the fix for that, or the way you'll complete the model, is by continuing to add additional atoms until all of the atoms that you've added have octets. If I add a second bromine with its own 7 valence electrons, now that second calcium electron has a spot to go. My new bromine is also stable, and now my calcium is as well, because it has lost its 2 valence electrons, and that almost completes the model. The only other thing is you want to show what is formed after this electron transfer takes place. So I'll draw in a large arrow to represent what we produce here. Of course, my calcium is still there, and it's still calcium, but now it has a +2 charge. I've formed a calcium cation, and I'll emphasize how many there are with this large number 1. I've also produced some bromine anions, because each bromine now has an extra valence electron, which means it has a charge of -1. It turned into an ion as well. Negative ions are called anions, and we'll emphasize that we're actually going to produce 2 of these bromines by putting a large 2 out in front. So this bonding requires 1 calcium for every 2 bromines, now called a bromide once it turns into an ion. We'll take this one step further and just add to my model by listing the formula of the compound that's produced here, calcium bromide CaBr2. That wraps it up for this video. Thanks a lot for watching.